All right, ladies and gentlemen, here we go. Chapter 3 review on inequalities. We're going to go through the whole review sheet together. I want you to make sure that you show work. Even when it's multiple choice, show the work on there. It's so important so you know what's going on. Okay? You're justifying your answer by doing that. So number 1, describe these solutions in words. First, you really should solve this. And in order to do that, you would subtract 1 from each side of the inequality to get h is greater than negative 11. So basically it means any number that is larger or bigger than negative 11. And when I look at these, I'm already going to wipe out a and c because those say negative 12. And then look for the difference between b and d and choose d, numbers that are bigger than negative 11. Number 2, graph this inequality. N is less than negative 2.6. All right, so first of all, I'm going to line in or focus in on this number. Well, I look at these, they're all negative 2.6. So I'm going to focus on the bit that it's less than. Well, that's not that guy and not that guy. Both of these are shaded to the left. However, my symbol is less than, which is an open circle, which is why you should choose C. Number 3. Jessica's drama class is performing a play. She wants to buy as many tickets as she can afford. Tickets are $2.75 each, and she has $12.75 to spend. How many tickets can she buy? Well, you could simply just start adding up $2.75, $2.75, and see where you get before you go over. Technically, algebraically, you'd be thinking this, 2.75 times, let's see, tickets. I'm going to use a T for tickets. And we have to stay under or exactly equal to $12.75. Now, when you divide, you're going to get this value. Let me crank on my calculator here. 12.75 divided by 2.75. And I would get this value, 4.63 repeating, less than 4.63. This is what it really looks like mathematically. In this case, what does it mean? I could buy 4 tickets. Yep, I can't buy 5. 5 is going to push me over. So again, you should choose C. Number 4. Ooh, I like the way this is worded. What is the greatest possible integer solution of this inequality? Now first, I would probably take this and solve it and see what you get. So grab your calculator first, because when you go and divide, obviously these are really nasty decimals, so we're going to get some complicated answers here. So when you take 25.085 divided by 4.872, here's what happens. You end up with x on the left here, and it's a less than symbol. I didn't have to flip anything because I wasn't dividing by a negative. And then you get this nasty thing here, this big long decimal, 5.148, blah, 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 blah. Okay? So now we have to think about, what does this mean? All right, now what does this mean? I'm asking you, what is the greatest possible integer? Integer. Okay, that means I can't have any decimal part in my answer. So B, even though that looks right, that's not okay. It has to be something smaller than 5.148 over here, and 5.15 you round it up. That doesn't work here. I need the integers that are smaller than 5 point something. So yes, 5 works, 4 works, 3 works, 2 works, and so on. But I'm asking you, what is the greatest one? And that has to be 5. So for number 4, up here, you should say A. That's the one that works. Okay, so put an A right there in the answer blank. All right, next, let's move on to number 5. Solve this inequality, graph the solutions. Well, this one should go pretty quickly. When you subtract 7 from each side, you get A has to be greater than negative 6. No flipping when you add or subtract. Now, whoops, whoops, whoops. I see 2 of them that say the same thing. Please make sure your graph matches what this statement says. Look in B. That isn't a greater than graph. This one has to be D, greater than. Next, number 6. Okay, is she numbers here? So you decide. I have variables on both sides. Okay, what are you going to do? Well, I hate negatives, so I'm going to subtract 1.8x from each side. Because then I'll end up over here with just -1 on the left. I have 1 4/10 or 1.4 plus 4/10 x. Oh, don't be whining about the decimals. Goodness gracious. It's just a number. When I subtract 1 4/10 from each side, those go to 0. This gives me on the left now -2 4/10 greater than 4/10 x. Now, before you get all whiz-banged about needing a calculator and whatever, I don't know if I've shown you this trick. If you just can't stand decimals, it's kind of like me. If you multiplied both sides by 10, you would get rid of the decimals, and this would look so much better. If I multiply by 10, this becomes 4x. You're moving the decimal point one spot. Multiply this by 10, I'd get -24. Okay, what a difference that makes, for goodness sakes, when you divide by 4, divide by 4. Now I get x on the right, I have -6 on the left. It's written this way. I can't do backwards stuff, but take a look. A was really left that way. If you rewrite it with the variable on the left, it would be less than -6. So careful, B does not work. It has to be A. All right, number 7. Carlotta subscribes to the Hot Burn music service. She can download no more than, no more than 15 song files per week. She's already downloaded 11. Write, solve, and graph an inequality to show how many more she can download. Well, she's already got 11, and she's got how many songs left? So I'm going to use S for songs. Okay, I'm going to say that's my variable. And she cannot go more than 15. She could be equal to 15, but not more than 15. And maybe you can just see that this has to be 4, okay, when you solve. So you end up with this inequality. S has to be less than or equal to 4. And when I look at this, okay, it's not A, not B. C looks good. D, no, not just less than. It could be exactly 4, so that's okay. And notice something here. They only graphed the whole numbers, 0, 1, 2, 3, 4, and the reason for that is this is a word problem. Even though the actual graph of this algebraically would normally be shaded in here and the arrow filled in, because this is a real-life situation, it doesn't make sense to have an answer that would be, oh, I don't know, like 2.5. Can you download 2.5 songs from iTunes? No. It has to be whole numbers. Can you download negative songs? No. That's why they stopped at 0. So when you see some real-life application, watch out for that. Okay, number 8. Straightforward, divide by 4. I don't have to flip. I should get x is less than 4. Notice why they're putting in 64. Oh, common mistake there. You know, instead of dividing, they multiplied. Not that guy. Less than 4. Yes, less than 4. Oh, oh, oh. Okay, so maybe you did a good job of eliminating ones that didn't make sense, but these two say the same thing, but their graphs are different. Make sure you choose the one with the correct graph, which is B. Number 9, which is a solution of both of these? Well, I think you should probably solve each of these so you can see what's going on. If I solve this one on the left, I'm saying I want my x to be a number that's less than 7, and at the same time, let's see if I subtract 6, I get x is greater than or equal to -15. So, which one of these numbers works? -16 is not bigger than there. Nope. 7 is not less than 7. Okay, it certainly fits this one, but not this one. -10. -10, yes, is less than 7. and it's greater than negative 15. Hey, I like to just double check here that I can rule out the other answer. 9 is not less than 7, so it should be C. Number 10. Solve and graph this inequality, a compound inequality. So when you do a compound one, make sure that you are doing the same thing to each section of the inequality. 3 less than 3x is less than or equal to 12. When you divide, oh, for goodness sakes, look how simple. Nice numbers here, okay? 1, 1x, 4. So x, oops, no. I certainly don't want this sign in there. This one should just be a less than sign. Ooh, close one. This is a less than or equal to. Okay, now they've separated this with the word, so if we want to write it that way so it matches up, I do this part. Yes, 1 is less than x, and at the same time, x has to be less than or equal to 4. When I look at my graphs, I should have an open circle at the 1. Yes, no, yes, yes. And then I should have a closed dot at the 4. No, yes, yes. Now, which way is it? If it's the word and, I'm talking about the overlap. So this one has to be C, not D, for number 10. Let's keep moving on. Oh, here's another one of these. What is the least possible integer solution of this inequality? 8.003x is greater than 23.898. And this one says, show your work, and then also record the answer in the grid. And the reason we have you practice some of these is because sometimes on the standardized tests, you have to take your answer and get it bubbled in correctly. All right, so goodness sakes, grab your calculator, okay? And when you do that, you get a number pretty darn close to 3, because you're going to divide by 8 3/1000ths. And you get x is greater than, and then you get this, 2.9861, blah, 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 blah. Okay, long decimal. Now, don't start writing in here 2.986. Read what it's asking you. What is the least possible integer? That means no decimals. What integers solve this? Well, 2 doesn't work, but 3 does, 4, 5, 6, comma, 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 so on. Okay? All of these are integers. There's no decimal or fraction part. They want what is the smallest one, the least one, the first one, and that is 3. So it doesn't matter where you put the 3, if you put it in this box, this one, but you have to make sure that you bubble it. Okay? Your answer is 3. Phew. And that's all you got to do. All right, number 12. Now I'm having you write the inequality and go from here. So this is just a graph, and it says, what does this look like? All right, well, I know that it's going to be a less than symbol because I'm shading to the left and it's an open circle. What variable are you using? Now, normally I'd say use whatever you want or just use x. Here, they actually put a little letter m, so I'll use m. M is less than, oh, well, what's that number? I don't know. It looks pretty close to negative 2.5 to me, so that's what I'm going to write, negative 2 5/10. If you had something close to that because it wasn't specific there, that's okay. But this is what I would be looking for, okay? The symbol and that it's less than. All right, 13. Sam earned $220 during winter vacation. He needs to save $75 for a camping trip over spring break. He can spend the rest of his money on music. Define a variable and write an inequality to show how much he can spend on music. Then graph the inequality. Okay, define a variable. So here I physically want you to write out what your variable is. Let's see. I'm going to use M because we're talking about money he can spend on music. So I'm going to let N represent the money. And then I have to write an inequality. Well, you might do the math first, or you might just start the inequality this way. Okay, Sam has got some money. And let's see, this was specifically money on music, okay? Money for music, because he's got money for camping and he's got money for music. So I want the music money, and then this $75 that he's tucking away for the camping trip has to be less than or equal to 220, because he's got 220, that's it. He can't go over that. He can spend exactly this, but no more. All right, when you subtract, this is the inequality I get. You subtract, I get what, 145, I think? M is less than or equal to 145. And this is actually going to be money. Now, I'm not going to be picky about you putting a dollar sign here. We're kind of implying that here. When you graph this, here's something important. Now, there's partitions here, and I'm not going to get picky about this. Just show me where 0 is. Put 145 somewhere out here. You have a solid dot here. And here's the deal. Normally, with a less than or equal to symbol, I'd say shade to the left, fill in the left arrow to negative infinity and beyond. However, this is money, and at some point we're going to run out. So what I want you to do is stop at 0. So on this one, even though algebraically you would normally continue on into negative infinity, here you should stop because it's a real situation and the money is going to run out and you would get to 0. That's what I'd have you do. Look at 14. Solve this one. Ooh, fractions. Is that going to make you upset? No. Just simply solve this. When you subtract 2 2/5 from, I see I've got tenths over here, I'm going to change this to tenths right away. Then it'll be easy. Or, you know what, maybe you want to change this into decimals. You could do that. This is 2.4 as a decimal. This is 9.5 as a decimal. If you like decimals better, knock yourself out. Those go away. On the left-hand side, I just have x. Less than or equal to. Let's see. Fraction-wise, I have 1/10 left. Whole number-wise, 9 minus 2 is 7. I didn't have to borrow. Here we go. Or, hey, if you are a decimal person, you could write that as 7.1 instead. I am not picky about using these intervals specifically. So just pick something for 0. Show me that this is going to be 7 1/10. You are going to put a solid dot and you are going to shade to the left, and you've got to fill in that arrowhead to indicate that it's continuing on into infinity. Go. This one, number 15. When you distribute the negative 6, I get negative 6y minus 12. All right, on the right-hand side, I have negative 6y plus 4. Press on, although at this point, maybe if you're looking at this for a second, you beep, 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 your algebra antenna are starting to react here because you're like, something looks funny here. If I would just press on like I normally would, I would probably add 12 to each side because I'm focusing in on getting my variable y by itself. Okay, or maybe you would actually, you know what you might do? You might have said, oh my gosh, I've got to get my variable on one side because it's on both sides. And so you would look at this, and first maybe what you would do is add 6y to each side of your inequality. And then, oh, this wipes out to 0y. This wipes out to 0y. And you're left with this statement. Negative 12 is less than 4. Dude, no more variable. Is this true? Why, yes, it is. And if you are left with a true statement, all of your variables are gone, it simply means this. All real numbers are your solutions. No matter what you start with, it's always going to be true. If you had gotten a false statement, you'd have to say there's no solutions. Here's 16. Go ahead, solve and graph. So show me some work here. You've got to show work. Do you see how I say show your work? That's because you get points for your work, ladies and gentlemen. Z is less than negative 4. Okay, so show me what you got. Graph it. Here's 0, 1, 2, 3. Since this one's easy, I'll actually use my intervals. Open circle at negative 4. Shade in, color in the arrowhead. It's less than. Look at number 17. I don't have a lot of room to write here, so I'm going to recopy this because it's a one-stepper. It's not going to take up that much room. All right, I need to clear that denominator, undo that dividing by 2. So when I multiply by 2, these go to 1s. That's exactly what I wanted. On this side, I get 24. You'll notice I didn't flip anything. I didn't have to. Everything was positive that I was multiplying by. Z is greater than 24. On this one, dude, don't worry about the intervals. Here's 0. 24 is over here in positive land. Open circle, shade to the right. Fill in the arrow. Next one, number 18. S is being divided by or over negative 2, greater than or equal to negative 4. Solve this by multiplying by this value that you're dividing by. It's clearing the denominator. Notice I have to multiply by negative 2 because you always want your coefficient to be a positive 1. These go to 1s, so I'm left with plain old S, goody goody. Negative 4 times negative 2 is positive 8, but because I multiplied by a negative number, you've got to flip it. It's less than or equal to 8. So put 0 somewhere, put 8 somewhere out here, 2, 4, 3. I'll just say it's here. Solid dot, shade to the left. There you go. Number 19, solve this one. All right, I've got a little bit of room here. I think I can squeeze some of this in. It's 2 steps. I've got to subtract first. I subtract 8. That leaves me with negative 2x on the left, negative 6 on the right. Now I'm simply going to divide by negative 2, so I get a coefficient of positive 1. For x, on this side I get positive 3, but hold your horses. You need to flip this inequality symbol because you divided by a negative. X is less than 3. Here's 0, 1, 2. Here's 3. Open circle, shade to the left. There we go. Number 20. Ooh, look at all that's going on here. Hold your horses because 3n and minus 4n are on the same side of the inequality. You need to combine like terms here. That gives me a negative 1n. Then I have minus 4, less than or equal to 3. Okay. First I'm going to add 4 to each side because these are opposites, they go to 0. And I'm going to come over here. So now I have negative 1n is less than or equal to 7. You're not done yet. I've seen some people leave this, and I'm going to say, nope, 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 not yet. You always want a coefficient of positive 1. So we have to go one more step. Dividing by a negative will make this a positive. So I get a positive n, 1n. This now becomes negative 7, but you divide it by a negative, so you need to flip the inequality. Here's 0. 7 is up here somewhere. You have a solid dot this time. Shade greater than, which means to the right. To the right. Next one. Oops, variable is on both sides. Let's get the variables on one side. Personally, I'd subtract 1x from each side, so this goes away. Those are opposites. They go to 0. And you're left with 3x is less than 18. Sweet. Divide by 3. X is less than 6. Put this on the line. X is less than 6. Yes, even if you can do it in your head, for goodness sakes, please show me the work. I got to get you trained this way. Open circle at 6. Less than is shade to the left. There we go. Whew. This one, a compound inequality. So when I solve this and subtract 4, I get on the first one, S is less than or equal to -9, or, let's see, this is -4, so if I add 4, that goes to 0. Add 4 over here. I get S is greater than +1. So here's what I would do. Like here's 0. This could be 1. So half of it is going to be greater than 1. And then -1, 2, 3, 4, 5, 6, 7, 8, 9. It fits. Here's -9. This one should be a solid dot and then shade to the left. Fill in the arrow. There you go. Okay. Ors usually look like this. They're like two trains heading in opposite directions, which means this guy is also falling into this category. So on this one, I'm going to say X. Let's see. For this part, I see less than or equal to, and it's -5, or X greater than 3. Done. That's all you got to do. All right, here's the big kahuna, the last problem. All right, Mrs. Williams is deciding between 2 field trips for her class. The Science Center charges $315 plus $5 per student. Hold your horses. Science Center, $315 plus $5 for every student. Okay? All right, the Dino Discovery Museum simply charges $12 for every student. All right, so now it says in Part A, Mrs. Williams has 28 students in her class. Calculate and compare how much it would cost for each trip. So for the Science Center, I have to take $315 plus 5 times 28. Let's see, that's 140. So the Science Center is going to cost me $445. Okay, that's here. The Dino Discovery Museum is going to be $12 times that 28 students. And on this one, if you either do it in your head or do it by calculator, you get $336. Now, hold on. Calculate. You calculated this one costs this much, this one costs this much, but that's why I underlined and compare. Write a statement to tell me something about what you found. And you should say something like this. You could say, the Science Center trip will cost more or is more expensive. And if you wanted to get real specific, you could tell me exactly how much more. Okay? It's over $100. Good grief, $109 more will cost $109 more. Okay, define a variable and write and solve an inequality to determine the following. For how many students will the Science Center charge less than the Dino Discovery Museum? Okay, so hang on. So now it says how many students. So we're not talking 28. You got to get the 28 out of your head now. I want to find the break point because maybe Mrs. Williams wants to bring another class along. I don't know. But we're trying to find how many students. So I'm going to use S. S is the number of students. And here's what I'm asking. When will the Science Center be less than the Dino Discovery Museum? Okay? Right now, at 28 students, it's more. I want to know how many kids would it take so this one would be cheaper because, you know, maybe that's really where I want to go, but I've got to somehow justify this. So notice what my pattern was. It was $315 plus $5 times however many students I've got. Okay? It's not 28 now. That was part A. I'm trying to find my break point. When is this going to be less than 12 times my number of students? That's how I was calculating my charges for the Dino Discovery Museum. Okay? Write the inequality. Now we got to solve it. All right? It's got variables on both sides. So what I would do is subtract 5s from each side. So 315 plus 5s is less than 12s. I'd be subtracting 5s. I'm subtracting 5s. That goes away. You get 315 is less than 7s, and then you have to divide by 7. Divide by 7. Okay. So let's see here. How many times does that go in there? 45? Does that sound right? Grab your calculator. My brain is not working this morning, but I think that sounds right. 280, 35, yes. Okay, so basically solving it now says this. S has to be greater than 45 students. Okay, so Mrs. Williams got to grab another class if you want to make this to be equitable. At exactly 45 students, I'm guessing what happens is they cost exactly the same. So I've got to have basically 46 or more kids. All right, so when you graph this one, you know, zero's down here somewhere. If I put 45 here, I have to put an open circle, okay? Now, hold your horses. What are we talking about here? We're talking about kids. Now, normally, you're going to want to just shade this whole line and fill in the arrow. But if I think that this is 46, this is 47, this is 48, you can't have partial kids. I can't have 46 and a half kids. It wouldn't make sense to graph that. I could have 46, I can have 47, I can have 48, and I can keep going this way. But in theory, it really doesn't make sense to just shade in the whole number line. It's kind of a picky point, but this is kind of a unique situation. I want you to graph this way. All right? Cool. Wow. This is the big kahuna problem right here. And this is the one that I want you to really pay attention to, because you'll get one just like this on the test. So this is really where it all comes together for Chapter 3. Awesome job. Use this as a guide. Your test looks just like it with different numbers. Good luck.